All right. That's pretty much it. I'm going to add one last thing here before we conclude, and that is when it says you're dead, let's say how many points you had. So, where is that? You're dead. You're dead. Your score was. You scored. Points. How many points? That would be snake.length. I guess, you know what? We could collect the time. You know, that's up to you. So, like, we'll say that ticks equals 0, and when we update, we'll say ticks plus plus. So then you could just say snake.length, so you can see how long your snake was, or you could say ticks, and so how long could you go? So even if you didn't grow, if you just kept playing forever and ever, you could do the score that way. So 36 points. There you go. So however you want to do it. If you want to do this tail length, just say snakes.length here. All right, that is snake. That's pretty much done. Again, this is very similar to what we've done before. We add a canvas element, we get the 2D context, and we use that to draw. In this case, I didn't have to create an array. I just kind of used the dimension size to know, for the grid. I just used the fact that I can't go to the left of column 0, I can't go above row 0, I can't go below row 20, and I can't go to the right of column 20. Actually, I'm sorry, column 19 or row 19. Because it goes 0 to 19. Then I have 20 rows, 20 columns. So I just drew cells everywhere, and I colored the cells based on if the snake has that cell within it, or if the food has that cell within it. Otherwise, I just color it a dark purple. I have a direction object, so this is an object that was new, and I can set properties. I can define properties, and I can set them. And that's what I did. I set direction.row to 1, direction.column to 0. It's kind of like what we were doing with these elements, but instead of having them numbered with indices like cell 0, cell 1, I could access the directions properties as direction.row and direction.column. I'm storing two numbers just like I did before, but this time I'm calling them by name, which is kind of nice with objects. And we're going to start doing more with objects, which are curly brackets rather than square brackets. We have our event listener is for keyboard presses, so that's a little new. I guess we did that in Hangman, I guess. And we control the direction based on what you press. The big difference is that we now have set interval here, which fires every, in this case, 100 milliseconds. We run these functions over and over again. So this is what we'd call a main loop. And this is what allows the game to progress even without you pressing anything. That's why the snake moves even when you don't press a key. So this is how games become more real-time, less like a board game and more like a video game. Doing things, the way a video game can be very different than a board game in that it kind of has a life of its own. It sort of acts on its own. You need a main loop for that, and here we have one. It's very rudimentary. It's a basic one. But they're all like that. Every game is pretty much update, draw, update, draw, update, draw. Even 3D games. All you do is calculate what you're gonna color each pixel on the screen, and then it colors the pixels every frame. That's all it does. update. So 3D games, you'd calculate where models are, where the camera is, where the light sources are, how the things should be looking to the camera based on perspective. And then it pretty much just figures out, if your screen resolution is 1920 by 1080, just multiply those numbers. That's how many pixels you have. And it just calculates a shade for every pixel. And then boom, it paints those pixels on your screen. And it does that several times a second. At 60 hertz, that'd be 60. Whatever your FPS is, it's drawing that many pixels every second. Update, draw, update, draw, update, draw. That's all it is. So this is very basic, but it is really the same fundamentals of every game you've ever played is built on a loop like this. Beyond that, all we did was we had a little algorithm, remove the tail element, add a new head element, make the new head element based on the old head, moved in the direction that you're going. And then we did not remove the tail element if you ate food. So only if you ate food did you not remove the tail element. Other than that, all we had to do was add collision detection with the edges, so detect when you hit an edge, and we ended the game. Otherwise, the game never ends until you give up, basically, and stop telling it to move. Or, oh, you know what? I may come back and add one thing. We didn't check to see if the snake actually collides with itself, so actually our game is not quite finished. But I guess I'll throw that in real quick. But that's pretty much the recap of this project. Alright, last finishing touch. Do we hit ourselves? So, here's our death check. If you're outside of this, you die. Let's do another one. So if else if, I guess. Well, you know what? I'm just gonna do I'll do it up above, I guess. So let self hit equals false for let part of snake. So check every body part. I'll call it body part again just to be consistent. So let body part of snake. If new head 0 equals body part 0 and new head 1 equals body part 1, then self hit equals true. So we'll say if this or this, if you hit this edge, this edge, this edge, or this edge, or if you hit yourself, then you'll die. So let's save that and try it. I need some food. I'm going to have to get a little bit longer to hit myself. Alright, I died. Alright, so that is the game. I hope that made sense and you're following along alright. And I will see you in the next set of videos.